Hello everyone, welcome back. This is Sushma. In this video, let's talk about instrumental variable in the context of randomized trial. So the question is, how do we measure causal effect if participants in a randomized trial do not follow the treatment that they're assigned to? Before answering that question, let's imagine a double-blind randomized clinical trial that aims to assess the effectiveness of a new drug A against the standard drug B in improving the recovery rate for a viral infection. So, researchers have enrolled 400 participants. Among them, 200 are randomly assigned to receive the new drug A, that means they are in the treatment arm, and 200 are randomly assigned to receive the standard drug B, that means they are in the comparison arm. In this context, there are several variables involved here. The first one is the outcome variable Y, which is the recovery rate from the viral infection. The second variable is the predictor variable. Let's name it X, and X would be equal to 1 if someone received drug A, the new drug A, and X would be equal to 0 if someone received the standard drug B. The third variable is not a single variable, but let's suppose the set of all other measured and unmeasured variables that affect our predictor variable and the outcome variable. And let's name it as U. And then the fourth variable is the random assignment itself. Let's name it Z, and the variable Z would be 1 for someone who is assigned to receive drug A, and the value of Z would be 0 for someone who is assigned to receive the standard drug B. So, in the context of this typical randomized trial, estimating the average treatment effect, commonly referred to as ATE, via intention to treat analysis, ITT effect, and per protocol analysis, PP analysis, would be the standard for evaluating the causal effect of this new drug B. However, these estimates may fail to provide a complete picture of the causal effect of the treatment on outcome if there is non-compliance among the participants. In that case, these estimates will be biased. I will show later in the video how the estimates will be biased and not reliable. But for now, let's think about a scenario where there would be a non-compliance in this study that we have imagined. So one scenario would be, suppose there are participants who were assigned to receiving drug A, but they actually took drug B. Likewise, there would be some participants who were assigned to receiving drug B, but they actually took drug A. So this is the typical case of two-sided non-compliance, and this can happen for a variety of factors. One example could be, for example, if there are some people in the treatment arm who had some adverse effect, and in that case, they might be switched from the new drug to the standard drug. Likewise, if there are some individuals who go out of the trial and take the drug outside, in that case there would be contamination and hence non-compliance. These are some examples. So, what would be useful to estimate in this type of case, in addition to the ITT estimate, the intention to treat estimate, or PP analysis? So something that would inform us about the causal effect of this drug X or drug A among the compliers, among those participants who took the treatment because they were assigned to that treatment arm. So this type of information would be very useful. And we can do that by calculating instrumental variable estimator. So what is an instrumental variable? A variable that meets these three different conditions, all of these conditions, is an instrumental variable. So the first, this is also called instrument. The first condition or criteria is it should have a causal effect on X. The second condition is this instrument should affect the outcome Y only via treatment X. That means there should be no other direct effect of this instrument on the outcome. And the third criteria is it should not share any common causes with the outcome. Y. So there should not be any confounding variable in the association between the instrument and the outcome variable. And it looks like in this double-blind randomized trial, the randomization variable Z is itself an instrument. How? So the first criteria it meets the first criteria because there is a higher probability to receive the assigned drug A if for the participants who are assigned to that treatment arm. And the second criteria is ensured by the double-blinded nature of the study itself. And the third criteria is met because of the randomization, ensuring that there are no other confounders that are in the association of the variable Z and the outcome Y. So we can also see it in the form of this diagram here. So G is a little bit hidden here. So there is a variable X which is associated with the variable Y, and there are different sets of variables measured and unmeasured under U that are associated with the X and Y. And then we have Z here that is only associated with X and not directly with Y, and no other any measured or unmeasured confounders. So now let's go back to the question that we had earlier. So what would also be useful to estimate? And we said that instrumental variable estimator would be useful to estimate. So how do we calculate the instrumental variable estimator? An instrumental variable estimator is the ratio of average causal effect of assignment to the proportion of compliers. So here you can see this numerator here is the estimated average difference in the outcome between those who were assigned to treatment, that is Z is equal to 1, and those who were not assigned to treatment, that is Y among those who were assigned to the comparison arm. So this difference is the numerator, and this is also the estimate that we have been referring to earlier, intention to treat estimate. So when we divide this intention to treat estimate by the proportion of compliers, the denominator here is the estimated value of treatment among those who are assigned to treatment minus estimated value of treatment who are not assigned to treatment. So that is the proportion of compliers, and this value would ideally be 1. If there was no non-compliance, it would be 100%, because all of those who are assigned to a treatment arm would be receiving the treatment, and none of those who are assigned to the alternate arm or the comparison arm will be receiving the treatment. None of them will be receiving treatment. So it will be basically 0. And 1 minus 0 would be 1. So the value here that we are trying to calculate, the instrumental variable estimator, would be actually equal to the intention to treat estimate. And in that case, we do not need an instrumental variable estimator. However, when there is non-compliance among the participant, we have this denominator value less than 1. And because of that, there is an inflation in the intention to treat estimate. So we have the different meanings of ITT and the instrumental variable estimator, unlike the earlier case when there was 100% compliance. And here you can see I have written it provides local average treatment effect. It's called local because this value here that we calculate ITT divided by proportion of compliers is no more about the total study participants. It's only referring to the uh, set or subset of study participants who are actually compliers. That's why it's not a global measure, it's a local measure. Now let's do some calculations. So let's go back to our, let's remember our study. There were 400 enrolled participants. 200 were assigned to drug A, receiving drug A, and 200 were assigned to receiving drug B. And out of this 200, let's suppose 150 actually received drug A. And in the comparison arm, out of 205 participants received drug A. And therefore, the percentage receiving drug A would be 150 by 200, 75% for the treatment arm, and 5 divided by 200, 2.5% for the comparison arm. If there was 100% compliance, this value would be 100 here, and this value would be 0. But here we are showing non-compliance. And in the third row, you can see the number recovered. Let's suppose out of 200 who were assigned to treatment arm, 120 recovered, and out of 200 who were assigned to the comparison arm, 90 recovered. Therefore, the recovery rate would be 60% for the participants in the treatment arm and 45% for the comparison arm. And now when we plug in this value in our earlier equation here, it will be 60 minus 45, that would be our ITT, 15% of ITT, and the local average treatment effect would be ITT divided by this proportion of compliers. So we calculate the late to be 20 point, late is here, local average treatment effect, 20.69%. So here we can see that because of the non-compliance, our ITT value is slightly larger than it would have been if there was high or full compliance. 10% of ITT would mean the average causal effect of the assignment on outcome, whereas this 20.69% would be interpreted as the average causal effect of assignment among the compliers. It is also important to note that one of the limitations of this estimator, instrumental variable estimator, is that if our instrument is not strong or if our instrument is weak, this denominator value here declines further, and that inflates the ITT value. And in that case, our local average treatment effect that we calculate may not be reliable. So that things should also be taken into consideration by the researchers. Yeah, so I hope you found this video useful, and you can also refer to this paper here by Hernan and Robbins if you want to learn more. And in the next part of the video, I'll focus on this instrumental variable approach in case of observational data. Thank you for watching.